Yeah, so we are facing some issue. IITM network is not working. So we are going to record this session and then we'll upload on YouTube. Okay. Okay. I think we are recording it now. Yes. Yeah. Yeah. Yes. What's your question? Can you repeat, Ayushman?
Sir, what will be the weightage wise syllabus for the end term examination?
We don't have any fixed weightage week wise, but you can expect like out of 20 questions, 5, 6 questions will be from week 8, 9, 10, 11.
So this time we will have approx 20 questions.
20 questions in end term.
Okay, sir.
20 into 5, so 100 mark, is it?
Hmm.
Are you describing DFS and 11th summarizing today?
We already done that. If you have any doubt, you can ask.
Yeah, can you please explain the DFS?
Okay. We'll do one thing. We'll quickly discuss DFS, then factorial, then we'll come back to a graded assignment, right? Entire
Yeah,
week.
last week we discussed like that. This week first we will go through DFS and factorial. After that, start the other things.
Yeah. Okay. Week 11. Yeah. Sure. Is my screen visible?
Yes, sir.
Okay. Great. So let quickly discuss about the recursion part first. Then we'll discuss DFS, and then we'll discuss week 11 grade assignment solution. Okay. So yes, what do you understand by recursion? Yes, tell me.
Sir means calling itself.
Yeah.
Simple.
So any procedure or any function, if a function is calling itself inside the function, then we can say that is basically a recursion thing, right? And that should have two things first. First, one is the base case. What is base case here? So there should be some stopping condition. If you observe what we are doing here, we are calling the function inside the function again and again. Okay. So there might be a thing, we'll keep doing this again and again, but there is no stopping condition for that. So that's why there must be some base condition and it should return some value. Okay. And then we can backtrack to get the final answer. Please mute. Yeah. So if you observe here, like what we are doing in the case of factorial, this when n is equals to 0, we are going to return 1. So this is basically a base condition for a base case for this particular procedure, right? Now, why we require this recursion, right? Suppose, let's say we want to find out the factorial of n. What we do usually, n into n minus 1 factorial, okay? We can write this as n minus 1 factorial. So whatever the process we have followed for n factorial, same we are following for n minus 1 factorial as well. Similarly, I can write like this also, n minus 2 factorial. So whatever the process I have followed for n, then n minus 1, same process I have to follow for n minus 2 factorial. It's just the input got changed here. Previously it was n, now n minus 1, and now n minus 2, but the process is remain same. I need to follow this entire thing, right? So for such cases, we can use the recursion here, right? So simple. If you are calling a function inside the function, that is basically a recursion. And this is basically a base case. Okay. And what if we have taken the negative number here. If I say n equals to, let's say, -2, in that scenario, this condition will never become true. And it will keep calling the function again and again, again and again. So it will go into an infinite thing, right? So we don't want that. So make sure while writing this recursion function, there must be some base condition or swapping condition, we can say. Okay. And how this particular recursion is working, let's try to discuss with one example. When I say n equals to 5, what is happening here? N is equals to 5. So first we are checking n equals to 0 or not. Then we are going to return 1, but n is not equals to 0. Then go for else block here. Now return is what? N into factorial of n minus 1. So again we are calling this function here, but the input is 4. So in the practice assignment or GA assignment, you must have come across this recursion. So how to solve such problems, right? So always follow this technique here. So whenever we see return n into some factorial again function, so do things like this, and again the output of this particular thing is going to write it here. So again factorial of 4 will be what? Again n equals to 4, not 0, return 1, no, go to else block. Again return n into factorial of 3. So that will be 4 into factorial of 3. Again we are going to call this function again here for n equals to 3. Again same thing here, 3 into factorial of 2. Again we are going to call the function here, this procedure factorial of 2. Again that will be what? 2 into factorial of 1. But now if you observe, n equals to 1 here. And here when n equals to 1, again this is not getting satisfied. Again return output is what? Of this n into factorial of 0. And now here n is equals to 0. So we are going to return 1. So output of this is basically 1. So entire this thing is 1. Now 1 into 1, 2. So output of this particular thing is 2. 2 into 2, 4. The output of this particular thing is 4. 3 into 4, 12. The output of this particular thing is 12. Right? 4 into 12, that is how many? 48. And the output of this is what? This one and 5. So output will be what? What is 5 factorial?
240.
120.
No, something is wrong. 4 3s are 3 4s are 12.
120.
Sir, 3 2s
Yeah,
are 6 will
120
come,
na?
no? 3
Yeah,
2s
3
are
2s are
6.
6. Yeah, that's what I'm saying. Yeah, 6. 6. This is 24. Now 120, right? Here you can see. So this is how this particular factorial works. Okay, so recursion works. So you can follow this type of structure to get the output of previous function here, right? So this is how this recursion work. And if you follow this technique, you can solve any question, right? So this is about the factorial parts. Here, same thing what professor has discussed. Factorial is suspended till the factorial n minus 1 is return a value. So same thing we have done here, right? So this is about the factorial thing. Anyone, any doubt in this one? Now same thing we can do here in the case of list as well, right? So in the previous thing, n was the input, right? But here we are taking list as the input, right? Some list. We want to find out the summation of all the element in the list here. So what we are doing here, again same thing. If L is equals to empty list, then we are going to return 0. Else we are going to return first of that particular list, like first element of list. Again we are calling the function here, and the input is what? Rest of the element, right? Except the first element. So again we are going to call this particular procedure and follow the same process here, right? So this is what we have done in the case of recursion, right? And here you can see, so there are two ways to do that. If I want to find out the summation of this one, 2, 4, 5, 7 element of this, so I can do one thing, take 2 first, then again take 4, then again take 5, then again take 7. So that will be the answer. But what I can do, instead of first, I can start with the last. Take 5 first, sorry, take 7 first, then 5, then 4, then 2. Okay, so any thing you can do here. So this is
The
what we are doing.
Yeah, excuse me. In base case, we have given the return value 1 for the factorial. Here we have given return value 0, right?
Yes. So that will be 0 at the end. Okay. So whenever we say rest of L, so in the case first we are taking, so if we see rest of and only if 7 is remaining, so that is 7. So only 7 will be the return, right? Then after that, the list will get empty. The next thing, in the next thing, it will be empty. So we are going to return 0. So plus 0 will come. And then we are going to do a summation of all these things. Okay. So we are removing one element from the list. And at the last, we are going to get the empty list. And then if this condition is true, then we are going to return 0. Okay. So this is how we are going for this recursion problem.
Excuse me.
And yes.
Hello. Can you just tell me, I mean, in this else statement, you have this return bracket first L plus list sum rest L. Now, this
Hmm.
list, the one is a list and the other one is an element, and they're both.
Here.
So, I mean, is this possible? I mean, in any kind of data structure where you have one element and one list being given back as
This is not a list. This
return?
is a function. This is a function. This is not a list. Output of this function is a number. Okay. This is not a list. We are taking list as an input, but output is different here. Okay. So let me take one example.
Sir, week 9, 10. Sir, week 9, 10 summary is done.
Sorry.
Sir, week 9 and 10 summary is done before.
No. We'll do next week. Okay. We are going to discuss week 11 in this session. Okay.
Sir,
So see.
week 9.
Yeah, next week we will do. Okay. All the 12
Okay,
weeks.
sir.
Yeah. This is not a revision session.
Okay, sir.
Okay. So see here what we are doing. Let's say, for example, L equals to this one. So we are taking this as an input. List is not empty, so we are not going to return 0. Go to L statement. Return first of L. Now what is first of L? First element of list. That is 2 plus. Now this is a function. We are calling the procedure again inside this procedure. That is a recursion here. But the input is what? Rest of L. Rest of L is what? Except the first element. That is 3, 4, 7. So again, we are calling this function, this procedure here for this particular input. The output of this will be what? Again, first element 3, again list of sum, that is again 4, 7. Again, we are calling this particular procedure here. Again, the output will be what? Return first of L, again first of L 4 plus list sum rest of L. Rest of L is what? 7 here. Again, we are calling this particular procedure here. Again, this condition is not satisfied. So again, the output of this will be what? 7 plus. Now, here rest of L is what? So here we
Empty
have
list.
removed this particular element. So S, that will be empty. Now at this particular point, we don't have any other element. So list is empty. Now we are going to return 0. Now output of this particular procedure is 0. Now 7 plus 0, 7. So that is output of this. 7 plus 4, 11. This is the output of this 11. 11 plus 3, 14. So this is the output of this, and 14 plus 2, that is basically 16 is the output here, right?
Thank you.
Yeah, this is the output of the function. We are not, this is not a list, okay? So if you observe based on this, like what you have asked the doubt, based on this doubt, you can see week 11 practice assignment question number 1. Okay, so in that you can see this thing.
This thing is.
Yeah. Okay, so this is about the recursion part. Anyone, any doubt here? So you can follow this particular approach. Always take the input and then go in this way. So you can track the output of the previous factorial as well, sort factorial procedure as well, and then you can backtrack to get the final answer like this. Okay. So yeah, this is about the recursion. And now if you observe, what is DFS? What do you understand by DFS? Yes, anyone?
Depth first search.
That I know here, but what do you understand by DFS? What is
Uh,
depth first? How it works?
we aggressively explore the edges, sorry, vertices, sir.
Yeah. So if I draw a simple tree here like this, yeah, let's say like this. So what we are doing here, suppose this is my root node or starting node, right? Now we can traverse to depth first search. So first we go to this root node. From this node, I can go to this, or I can go to this node as well. So we'll fix any one route that I am going to explore, always the left most node first. For example, in this case. So what we will do, first I will explore this node, but from this I can go to this and this. But what we are assuming, we'll always go for a left node first. So I will go to this particular side. Again, I will explore that. Again, if you observe, I can go to this and this node. So again, I am assuming that we will go to a leftmost node. So again, I will go in this particular direction here. Again, if you observe, I have only one node to explore. So I will go to this particular node. Now what happens here? I don't have any other node to explore. Now in this scenario, here comes the concept of backtracking. So we'll go to previous unexplored node here. So this is already explored. Go to here. Here you can see now we have left with the rightmost node first. Then for this particular node, we already explored the left side. Now at this particular point, we backtrack to this particular node, because at this point also we don't have any right node here, right? So we'll backtrack to this particular node, and again we'll explore this rightmost node now. Now if you observe, again I will go to this particular node, explore, but I don't have any node to visit. Again I will backtrack to this node, but already explored, and I will backtrack to this particular root node. Now, if you observe, in this way, we have explored the leftmost subtree here.
Sir,
Now, again, I will go in this particular direction.
sorry to interrupt, but then there are, I mean, there are questions in exercises in which they are asking what would be the, let's say, on the third node on the right side, in how many steps you would reach within DFS and compared to BFS also. So, is there any, I mean, specific form? Because in those questions, it is not told ki you will have to take the leftmost side or alphabetical side. In case I don't, if I have to follow my own, understanding, I may take the left branch or right branch, and in that case, the number of steps required to reach a particular node would be different from me and some other person.
Yes,
In
yes. It
that
depends
case,
on what we are following. Yeah.
In that
but then
question, it's given alphabetically.
so you have to, I mean, do it alphabetically in all, or I mean, is it set for
All,
all?
but while backtracking, you will not see that.
So, if in the question it is mentioned, then we have to follow that. Okay, we'll discuss after this one, grade assignment solution as well. Okay. So, this is how we explore a thing like depth first search. We go in depth, then we backtrack to a previous unexplored node. Okay. So, the simple concept here. But how, what is the procedure for this, right? So let's discuss that here. Yeah. Okay, here's the graph. So what professor has discussed, let's do that. Yeah. So here you can see. So this is the graph given to us, right? So we are going to start with the graph 4 here, sorry, node 4 here, right? Now I am at this particular node 4. So I can go to 1, I can go to 5, I can go to 8. Now what professor has said in this, we are following the which one is minimum out of this 1, 5, and 8. So 1 is minimum, so I will going to explore on this particular side, right? So we are following the lowest number here. So if you see from 4, I can go to 1 like this. But from 1, where I can go? I can go to 2, I can go to 3 as well. But again, which one is minimum out of 2 and 3? 2. So I will explore a 2 now. But from 2, where I can go? I can go to 1, I can go to 3 as well. But 1 is already explored, right? I am not going to visit it again. I will go to a 3 here. Now, at node 3, where I can go? Again 1 and 2, but both are already explored here. You can see both are already explored, because we are keeping a track of that visited node inside this dictionary. So we can track the key, and we can see we already visited that particular node. Now, in such cases, we are going to backtrack that. Where we are going to backtrack to previous explored node. So from I will go to 2. So here you can see at node 3, I don't have any other thing to explore. I will go to node 2. Again, I will backtrack to node 1, because I've already explored all the neighbors. Then again I will backtrack to node 4 here. Now if you observe previously, we have started with 1, but still 5 and 6, 8 is remaining. Again out of 5 and again out of 8, which one is the lowest? 5. Then I will explore the node 5 here like this. So again I have visited the node 5. Then from 5 I can go to 6, I can go to 7, I can go to 4, but 4 already explored. So from 5 I can go to 6 or 7, but which one is lowest value? 6. Then I will go to node 6. Again from node 6 I can go to 7 and 8. Again which one is minimum? 7. Now at this particular point, if you observe, I can go to 6, I can go to 5, but both the nodes are already explored, right? I will backtrack to previous node here, that is basically 6. But if you observe from 6 I can go to 7, 8, 9. So I can go to 8 as well as I can go to 9, right? So out of this 7 and out of this 9 and 8, which one is lowest? 8. Then I will go to 8. Again from 8 I can go to 4, 6, 9, but 4 and 6 already visited. We have this one, right, in the dictionary. So we left with 9. So I will go to a 9 node. I will explore that. Then I can go to node 10. Now if you observe, I don't have any other node to explore. Then I will backtrack to all the nodes like this here. And if you see, I have already explored all the nodes. Then I will stop the procedure here, right? So in this way, how this DFS works. Any doubt here? How it works? Anyone?
No.
Okay.
No.
Now let's discuss this procedure here. So what we are doing, if you understand the concept, now let's come back to this particular procedure of DFS. We are taking the graph as an input, visited a dictionary here. So initially empty dictionary, then that particular node from which we can start, right? A key visit is set of node that can be reached from right? Now let's take that a node. For example, we have taken 4. So visited so we are going to add that particular node 4 inside the dictionary. So that was 4 and the corresponding value was true. Okay. Then for each j in columns of graph, the columns of graph is what? The list of all the nodes here. If graph ij, so I is what? 4 here. And equal to 1 is what? There is a h from 4 to j. So if there is a h from 4 to j and not is key is a function which is going to check whether that particular j is the key in this particular dictionary or not. Now, if you observe for j value, any value, let's say 1 3 1 3 5 1 5 8, yeah. So if you observe from 4 I can go to 1 5 and 8, right? So if I like while iteration doing this for loop, the columns of graph will be what? The list of the nodes starting from 1 2 3 4 till how many nodes we have? Till 10. So for j equals to 1, we'll check no, there is no path from 4 to 1. Again, in this way, we are going to go through for loop, but when we say 1, so when the value of j equals to 1, now here is an age equals to 1, that condition gets true. Again, we are checking whether that particular 1 is already in this particular dictionary or not, but that is not the case. So that is basically a what? So output of this will be a false, not a false will be true. So this is also true. Then if both the conditions are true, then we are going to visit equals to what? Again, we are calling that particular function here or procedure here, graph visited, and now that particular node is j. So instead of 4, whatever the node we have explored and we have gone to that particular node, that is taking as an input. And again, we are following the same process here, right? So this is how this recursion is working in the case of a DFS. The same process we have followed here now. First, we have gone for from 4 to 1. Again, we are checking from 1 where I can go. Okay. So now in this case, the value of this particular thing will be I. And again, we are checking for all the nodes here, right? So in this way, this particular procedure is working. So and output of this will be what? This particular dictionary, what we got at the last. Okay. Any doubt how this DFS is working, this particular procedure?
But in the pseudocode nowhere mentioned after this J has been visited, which order is supposed to move to next?
Yeah, so that is not there. So see, we can follow any order, but in the question which
Mhm.
mentioned, then we have to follow that only. Okay.
Sir, I have a
So
queries.
it
But here, if you observe, if we see columns of graph, so it will start from 1 to 10. So in this particular order, right? So lowest,
Mhm.
whatever the node will be, that going to taken, right? So same thing will happen here. We are going to get the same nodes here.
got it,
Yes.
got it.
Yes.
Yeah, sir, I have a query regarding this pseudocode. So the value of I should be only for whole code, right?
No,
Whole
this one
process.
initially.
Yeah, yeah,
No, we have decided that we are going to start from node 4. Okay, so
4.
that's why we have taken I equals to 4 for starting purpose. Okay, we are
Yeah,
starting from
so
this particular node. Yeah.
for whole process, I should be only 4, right? Only
No.
J would be changed.
No, see, initially we are taking I as the input, that is, we are starting from node number 4,
Yeah,
right? Now,
right.
at this point, when j equals to 5, this condition becomes true. The value of
Mhm.
j is now 5. So now we are calling this particular function again here, right? So input will be
Okay.
what? Same graph. Now this visited, inside that we have this 4 equals to true. And now here that is 5. So when you are going to call this particular procedure again, the input will be 5. So now instead of I, you need to
Okay.
consider 5 and repeat the same process here.
So if in every time I would be changed, right? According to
Yeah, so this is
okay.
just the input what we are going to take from this particular thing, right?
Okay, that would be initial input, I think, for in first time. Okay.
Yeah, for the first time, we can start from any node. I can start from here, I can start from here. So for the example purpose, we have started from here. So that's why.
So graph is a dictionary. DFS graph, visited graph is
A graph, yeah. So graph, we can convert this graph in the form of matrix that we have discussed, right?
okay.
Yeah. Okay. So this is about the DFS, how it works. Okay. We don't have BFS in the lecture. Okay.
So there's one doubt on this.
Hmm.
When you convert a graph to matrix,
Hmm.
normally you would have, if you're moving from an outward edge from I to J, the value would be 1. But if it is, there's a question in which there is about finding out parents from, the line of parents in the question. In that case, if you move, surely if A is the father of B, B cannot be the father of A. It's one-sided. So in that case, whether you will have the the invert from J side or the invert from I side is written as negative. So what does that mean?
Okay.
Can you please
So
explain converting graph to matrix once, please?
And further, if it is a directed matrix, directed graph, if you have I to j, let's say 1 to 2 is 1, ijth value is 1. But then if it is from 2 to 1, then will it be 0 or will it be -1 in case of a, both side graph, whatever we call directed or undirected graph?
yeah, see,
If it works both side, A is a classmate of B and B is a classmate of A.
so we have this 4 node like this, and here it is a it's not a directed graph, okay? Undirected graph. So 0, 1, 2, 3. So how the adjacency matrix will look like here? Here we have 4 nodes, so that will be 4 by 4 matrix, okay? So 0, 1, 2, 3 column number, and 0, 1, 2, 3 row here like this, okay? Now from 0, now start with 0. From 0, where I can go? I can go to 1, I can go to 3, I can go to 2, right? So from 0, I cannot go to 0 again. So here that will be
Then
0.
the principal diagonal will all be 0.
Yeah. So this will be all be 0. So 0 to 1 I can go. So that will be 1. 0 to 2 I can go. That will be 1. 0 to 3 I can go. That will be 1. Again, from similarly from 1 also I can go to 0 and 3 only, not to 2 and 1. So this will be 1. Again, 1, 2, sorry. 1 to 0, yes, 1 to 1, 0, 1 to 2, again 0, 1 to 3, so again we can go, that will be 1. So this is in the case of undirected graph. What happens in the case of directed graph? So that a thing will be 0. Okay, like
Okay.
this.
So
So
if there is, I mean, if there is no edge going from, let's say, 0 to 1, it would be, I mean, in case of parent, in which you have only one single direction going from 0 to 1, or let's say 1 from 3. So then it would be straight away 0, not minus
0
1,
only.
right?
No, not minus 1. Okay, so here we are going from 0 to 1, but I cannot go from 1 to 0 again, right?
No.
Yeah, so that will be 0 here. So 1 to 0, this will be 0 in the case of directed. Okay. So we have discussed this in the first few sessions, like week 9 something. Okay, so you can refer to that.
Excuse me, sir. Actually, I
Hmm.
also have a small doubt. The
Hmm.
pseudocode which is given for DFS, like we'll first taking the example which is already given. We'll first go from, maybe I choose 4 as a node. I go to 1,
Yeah.
then 2, then 3, and then I have to backtrack to 2, then 1, and then 4, because my nodes
Yes.
have exhausted at 3. So I have to backtrack actually. But the
Yes.
pseudocode, it like nowhere mentions that we have to backtrack to
No,
the
no.
previously visited node.
See, here, let's say for example, starting from 4. So here we have added that 4 is already visited inside the dictionary, right? So that is what true. Now here we are checking for which value of j we have this 1. So for we have 5. What was that? Yeah, 158, right? 158. So it will start from 1. Columns of graph is 1, 2, 0 till 10. So when j equals to 1, that was true. This is become true. Now here you can see j is 1. 1 is not inside this particular dictionary. So that is
Yes.
basically false. Not of false will be true. So entire thing is true. Again, we are going to visit, call this particular procedure for j equals to 1. We will do the same thing here. Again, if you observe from 1, which condition will get satisfied? 2. Again, from 2 will get satisfied 3. And if you observe, let's take now j equals to 3. Sorry, j equals to 3. And here we are going to again call this particular procedure here. Now what will happen here? See, when I say I'm at a node 3, so I will be 3, and we are going to start from again 1 to 10. So 3 to 1. 3 to 1, there is the age. So this will be true, right? But what about this particular condition? Visited
False.
J1.
Yes,
This
sir.
will be
This will be
false.
false.
Yeah, 1 is already is the key inside this particular dictionary. If you observe 4 true, then we will have that particular one already, right? So that will be false, right? So we are not going to visit again that node again. Okay, so we are going to skip that again. What we are going to do, going for a next thing, next node here, right?
So, sir, since there is no node from 3 which we have not visited, so then it will go to, it should go to 2, because we'll backtrack to the previously visited node. Because
Yeah.
like once we take 3, then there is no node from 3 which we have not visited. We have visited 2. So now we need to backtrack to 2. And there also there are no node which we have not yet visited. So we have to backtrack to 1. So how, like, is this code making it clear that we have to backtrack to the previously visited node?
Okay. Yeah.
Sir,
So,
actually,
see
what previous week, the same question we have asked, ma'am has told that the whole code is not written. Since like it's a big in pseudocode, we can't represent such statements, so we are just assuming
Yes.
she has said, sir.
Yeah. So if we follow this, like what is going to happen? This will, and after entire for loop, this condition will not become true, right?
Right, sir.
So output of previous thing was we are going to return visited here, whatever the dictionary we had, right?
Okay.
So yeah, in this way, backtrack. Yeah. So that will be the output here. Visited. Yes, we cannot. Yeah. So instead of node reach from I visited includes all the node connected. Yeah. Yeah, so backtracking we have to see here, right? But this is how we explore the node, right? We proceed with the node here. Okay. Okay, so in the previous few sessions, I think we have discussed assignment solution, practice assignment. Any doubt in practice assignment? Or do you want me to discuss graded assignment solution?
Yes, sir. Graded
Yes.
assignment.
Yes, sir.
So why are you
Sir, I
uploading the
have a
graded assignment solution?
Sorry, can you repeat?
Why are you uploading the graded assignment solution?
Inside the week unit only you can see. Okay, I think for week 11 we have not updated. We'll do that. But for
Yes, sir.
every
For
week
week
inside
11.
the week unit, there is a solution. Okay. So let's
Then how can I get the graded assignment solution now? Because I need it.
no for week 11 it is not available yet, but for other weeks you can go. Just go to that particular week unit, and after just scroll down. After grade assignment, we have uploaded the PDF grade assignment solution, right? For 10 you can see. 11 we have not uploaded it. We'll release. Okay.
Sir, I have a question in activity 11.2.
Yeah, let's discuss this first. We will go back to activity questions as well. Okay. So yeah, here you can see reverse is a recursive procedure to reverse a list. Choose the correct code fragment to complete the pseudocode given below. This is a MSQ question, right? Now, this is a procedure given to us, and what is our requirement? Reverse a particular list, right? And we need to fill this particular code here. So in this way, this question, we need to go option wise here. So does anyone tell me how we can proceed with this? How did you solve this question? It's a graded assignment, right? You must have
We
solved.
can
Yes,
take
sir.
one example, sir.
Sir, from 1 to 5, I've taken an example.
Now I want to reverse this particular list to 7531. Now let's try to take option one by one. So here, going to take this as an input. Length of L, number of elements is what? 4, not less than 1. So we are not going to return L. Go to here, right? So if it's not true, then what we are going to do? Let's go with the first option. So what we are doing? Return. So this, you can see list is there, right? So this is what? Last of L, and this is list. So last of L is element, and this will be a list. What is last of L here? 7, right? So we are putting this 7 inside the list plus plus. Again, we are going to call this particular reverse procedure for init of L. Init of L means what? Except the last element here, like this. Now again, if we call this, again length is not equals to or less than 1. Again, we'll go to this particular thing. Again, we are going to consider last. So here again last will be what? 5. Again, we are going to call this particular procedure here again for init of list. Now in this case, we left with 1 and 3. So is this correct? Are we going to get the reverse list?
Yes, sir.
Yes,
Yeah.
sir.
Yes.
So if you observe, so in this way, we are going to get the 1, and then here we are going to get a remaining is what? Reverse 3. That is a list as an input. But here less than equals to 1. So we are going to return L, that is basically 3. That is a list here. This is also a list. Then we are simply going to append that one like this. Okay. So we are going to get 7513. That is the reverse of this. So option A will give me the required answer. What about B?
Wrong answers.
So, but this procedure was not defined for the zero length of the list now. For the zero length, nothing is there up.
No, less than 1 is there.
Okay.
Less than
Less
or
than or
equal to
equal
1.
to.
Okay.
Your voice is breaking. Is it for me only or
It's for you, sir, I guess.
Done.
for everyone?
Now your voice is breaking.
Okay, sorry. Okay, yeah. What is your question? Can you repeat? Am I audible now?
Done, sir.
Yes,
Done. I
sir.
got it.
Okay, yeah. What about option number B now here? Return of first list L plus plus reverse list here. So we are going to take the first element, what is there inside the list, and then we are taking the remaining of that. Is this the correct one?
No.
No, sir.
No, sir.
So in this way, we are going to get the same list, not the reverse of that. So we are not going to get the reverse list, not B is correct. What about C?
Right answers.
Right, but how? See here, last element, then plus plus, what we are going to append? What is this? Init of rest of L. So rest is what? We have removed the first element, then initial of that. First we have added here. So how this is working? Yes, anyone can tell me? If we use option number C, how it will work?
Sir, it will first remove 7 and 1, and again it will recursive processes done for 3 and 5, and we'll get the reversed list by that way.
So in the option A, what we are doing, we are appending this like this 7, then 5, then 3, then 1. In this way. In the option number C, what we are doing, 7 is there, 1 is there. Again, we are doing the process for that particular thing. Okay, so output of this will be taken here like this. So if you follow this, so we are removing the first as well as the last. The remaining will be what? 3 and 5. Again, we are doing the same thing for that, right? So in this way, if we do the same thing, so 5 will be here, 3 will be here. Yeah. Okay. What about option number D?
Dental concentration.
Wrong.
Yes. Any doubt?
No, I've done this. Oh, you
Any
also
doubt?
Yes.
Sorry,
Yes.
not
நீங்க
audible.
No, no, it is to. He has to mute the mic.
Okay. Yeah, I thought you were asking that question. Okay. So what about option number D now? First, then last. Anyway,
Same.
we are not going to get. Same is there, but in the same list we are going to get. So not D. What about
Yeah.
E?
Right answer,
Last.
sir.
Correct.
Okay. So what's the difference here? Yeah. Anyway, if we remove first or last first first, output will be the
Both are
same in both the case, right?
Yes, sir.
So this
So-
rest and init functions do same thing.
Init or rest. So
Yes.
rest, what it will do, rest will remove the first element and it will return the remaining element in the list. What init will do, it will remove the last element and it will give the
Initial
remaining
part.
element from the list. Yeah, initial element from the list, except the last one, and the rest except the first one. Okay. So if we talk about that 1, 3, 5, 7, the rest of that will be what? 3, 5, 7. And init of that will be what? For this particular case, 3 and 5, right? Now both the cases, this will be the output will be the same. Okay, so that's why option C and E both are same thing.
Excuse me, sir.
And option A, C.
So what if the
Yes.
given list is in jumbled order? Like here the list is in ascending order, but what if it is in jumbled order? Like 3 first, then 1, then 7, then 9.
Okay. Can you repeat what if?
What
So
if
that
the
I
list
missed.
in the jumbled order?
In the
Here jumbled order means
okay.
there is no
Yeah.
sequence, proper sequence.
1, 5, 3, 8 like this, right?
Yes, sir.
Yeah. So we are not keeping a track of order here. We are simply reversing the list. That's it, right? We don't want an increasing or decreasing order. We are simply reversing the list. So output should be 8, 3, 5, 1. Reverse of that. That's it. Okay.
Can you please explain the option with this in this order? Using this order.
Yeah. So same thing here also. Like instead of first and last, here we are simply like we are not keeping a track of any order here. We just want to reverse the list, right? So if you go with the option number A, the last of L will be what? 8 plus plus reverse of initial list, right? Sorry, last of L will be what? 1 here. Okay, let's take this. Sorry, this is the output, right? Yeah. So here the last of L is what? 8, And here reverse of init of list will be what? This one, 153. So again, we are going to do the same process again and again here, right? So order doesn't matter here, okay? We are only want to reverse the list. That's it, okay? Not in specific order.
So what if in the last position 1 is there then? In the list?
Only one element like this.
No, matlab 5318. Matlab 5381 like this.
Again one.
Yes.
Yeah, then again that is going to consider. We are not keeping a track of duplicate also. We simply want to reverse that. So it will be 1, 8, 3, 5, 1. That's it, right?
Yes, sir.
So simply reversing the list. That's it. Not in any specific order. We are not taking the unique values, nothing. Simply reversing the list. That's it. Okay.
Yes, sir.
Okay. Yeah.
Just
So
1 minute.
let's. Huh?
Excuse me. Sir, in this very question, now in the C option, which is correct also in this case, you have return last L. This is an element. The last is first L. That is again element. And in the middle, you have a list.
No, this is
Yes.
not a list. We are calling the function. Okay. We are calling the function, and the output of this particular function will be the list. Okay.
So that is what I am saying. That you have the answer is the even the last whatever you get in the last step would be in the form one element in the first, last at last there is also an element, and then in the middle there is a list.
No, this is the list. You can see square bracket is there. Square bracket, then last of L, right? So last of L is the element, but if we put in the square bracket, that is basically a list, right? So this is also list. This is also list.
Oh,
This is
okay.
also
Sorry.
list.
I I missed
Yeah.
this bracket.
Sorry. Okay. So this is
Uh,
about the.
Sir,
Yes.
this init and rest does not returns the element that they have removed. They only return the list now.
Yeah, this will remove the list of remaining element. So rest will what? Except the first element. Init will be what? Except the last element, all the element, but list. Output will be list. Okay. Rest and init output will be the list, and first and last output will be the element. Okay. Remember this one. Okay. So here we have question number 2 to 4. An auto grading system for an online course is designed in the following way. A student submission is recorded as a dictionary with the following keys. So roll number is mapped to student roll number, and time of submission, score mapped to student score. So here we have given the example for that, and each student can take multiple submissions before the deadline, right? So this is you can see here roll number 12, and then every time a student make a submission, directory corresponding to it appended to the end of the list score. Okay. So this is the scores sample example given to us. Pseudocode is given. Okay, is present, gets up. What is the question? Okay. So answer question 2 to 4 after executing the pseudocode given below. Okay, and this scores is given as an input, submission, get sub score, right? Where is these present? Here, okay. So what we are going to do, we are taking this as an input, go to here, submission, get score, score as an input, but what is this get sub? So here is a procedure, we are calling this particular procedure here now. For that, L is basically a score, that list, okay? So what is score here? List of a dictionaries, right? Here you can see it is a basically list, but the elements are the dictionary. Now again, if length of L is basically less than 1, we are going to return that L. Or if this is not true, what we are going to do? First sub is first of L, rest sub is rest of L. Now what is first of L and rest of L here for this case? Yes, anyone?
Dictionary
First
of
dictionary element is
Yeah.
first of L.
So first will be this one, entire thing, right? Last will be this one. Because here dictionary is the element here, right? So this will be last, that will be first.
Sir, I think they asked rest, sir. Rest of L.
Okay, sorry, rest of L, right? So rest means what? Except the
First
First
element.
element remaining list.
so this is the first and remaining are the rest one, right? So we are taking that as an input for first and rest. If is present, rate sub, first of sub, what is this roll number? What is this output of first sub and roll number? So first sub it will
12.
be a dictionary and roll number is a key. Corresponding value is what? 12 here. So here we are taking 12 and rest is what? Remaining entire list, right? Now what we are checking here? Is this correct? Is present, rest and then 12. So what is this is present here? So we are going to call the
Function call.
procedure again here like this. So now let's discuss what it is doing. It is taking that roll number and list as an input. What we are doing for each D in L. For each D in L, it means what? For every dictionary in that particular list L, if D roll number. So for that particular dictionary, if we have the roll number, whatever the roll number we have, let's say for example 12 is equals to that particular roll number, then we are going to return a true, right? Yeah. So what we are doing here, this is a 12. So this will be 12 and L will be
Sir,
the remaining one.
here I have a doubt. In D of roll equal to roll number roll, like how is it returning numbers? Because we are saying return equal to roll means it should be the word roll, right?
No, roll is the variable here and the value of this is what we are taking as an input. So roll is 12 here, so this will be 12. So when
Okay,
we
sir.
call this particular procedure, we are taking this as an input, right? So instead of roll, we have 12 here, right?
Yes, sir. Got it, sir.
Now what we are doing for each D in L, and what is L? Rest of sub. So for every dictionary in this particular list, what we are trying to do, for that particular dictionary, we are checking if D roll number. So for that dictionary, if the roll number is what? Equals to 12. So for the first scenario, we have a 20. That condition is true? No. Right? So this will be output of entire thing. For the first iteration will be 20, not equal. So we are going for a next iteration. The next iteration, what will the next element? Roll number 12. Again here, if you see, this condition is true now. Now, if this condition is true, 12 equals to 12, then we are going to return true, right? So output of this entire thing will be true here. What we have done is present. So the output of this particular function is true. So this is what entire thing is true. Now, if this is true, we are going to return get sub rest of sub. What is rest of sub again now? Remaining except the first one, we are going to return this one, not return taking as an input. But again, here we are calling the function again, right? Procedure. Now, in this case, what will happen? Except the first element, right? We are taking as an input. Hello? Now, this is
Yes,
the
sir.
input.
Yes, sir.
Yeah. Any doubt up till now?
Sir, in this procedure, get sub. After having assignment of this first sub equal to first L, this had taken the first entry. After this rest sub is taking rest L. That means the second one is also excluded and the other ones are taken out. So this will miss the one, I think.
No,
We should
what you
have a
said?
check. This first sub will take the first element. First element is taken out, and then rest sub will take the rest L. So it will miss the second one, na, because it removes. Oh, okay, sorry.
No,
This
we are
means the
not
last one,
removing
sorry.
here.
Yeah.
Yeah. Only.
Okay.
Yeah, we are not removing. Okay.
Yes, sir. Yes, sir.
Only in it and rest will remove the element from the list. Okay, that's
good. Rest will remove the last one.
Yeah. So what we are doing here? Yeah. So this will be taking as an input, except the first element here. Again, we are calling this particular procedure again. Now, what happened in the previous case, if you observe, again, we are going to take this as an input, checking length is equals to 1 or less than 1. No. First sub will be what for this particular thing now?
Second element.
Second element in the list, that is what? This
20.
particular thing, right? And the rest will be what? The next three. Here rest sub will be what? This one, remaining one, right?
Yes, sir.
This is my first sub, this is my red sub. Again, we are going to call this particular function is present. Now here my first sub is second element. So what we are doing here? So first sub roll number 20. So taking 20 as an input, L is what? Remaining one. So remaining one will be this one. Again, we are applying the for loop for every dictionary. We are checking the roll number value. Do we have that condition? Roll number equals to 20. Yes.
Yes, sir.
For the third iteration in this particular for loop, for the first dictionary, we don't have 20. For second dictionary, we don't have 20. But for the third dictionary, for this one, we have roll number 20. So again, this will get true. If this is true, again, we are going to return true. Now again, if this is true, again, we are going to call this particular function here. But again, rest sub will be what? Rest
Last
sub will
three
be now
element.
Last three
last three
dictionaries.
element, right? So again, we are taking this as an input. So same thing will happen. Again, now I'm quickly doing. See, can I say this will be my first and remaining two will be my last?
Correct.
Yes, sir.
Again, if I apply that is present, so 12 is present in this last as well, reverse last sub as well, right? So again, that
Yes,
will be
sir.
true. So again, we need to return true. Now again, what will happen? This will be my first and this will be my
Rest.
rest. Now check here what is happening. For this first roll number is 12, right? Rest sub is what? Remaining 1. Now if we call is present here, now see what is happening. 12, we have only one dictionary, so that is what it is. 20, not
20.
equal, right?
Yes.
And we don't have any other element also. So 20 is not equals to this 12. Now this is going to return false, right? Now if this is false, we are going to go else block here. Hello?
Yes, yes.
Yes, sir.
And when we are going for else block, when my first will be what? This one, and the rest will be what? This one, right? For this case only we are going to else block.
Correct.
Yes, sir.
Now, what is first of this one? First sub,
The
Second
first,
last
the
dictionary.
12.
entire this one, dictionary, plus get sub is again we are going to call this particular procedure for this particular thing, right?
Yes.
Yes, sir.
So, but what will happen here in this case? Tell me. We just have one element inside the list now. This will be true.
It will return that list itself.
Yeah. So we are going to return both the element
Yes.
inside the list. This one plus this one, right? We are going to merge two lists here. So after going through all the things, what we are going to get? These two lists. Output will be what? Return that list and remaining list. So these two lists will be the output. So the value of submission is what? This should be the output. 12, 20, then 23, 50, 23, 20. Okay. Now let's see. 12, 20, 12, 20, 23, 50. Yeah. Option number C here, right? Any doubt?
Sir,
Hmm?
in the first iteration, like we'll have first of courses. So could you go to this course data set? Sorry, the data. Yeah,
Here.
here. The first dictionary will be added, and the second dictionary is not is present. It will not be true, right? Since roll number is 20.
Yeah, here this
No,
will be my
no,
first.
no, sir, not that. The first, like I'm starting with the first iteration. Yeah, for
this,
that. When we go for check when we go for checking the second iteration, in that we'll have 20 as the next.
Yes. So
Then
this is for the
it will,
first iteration, right? In the
yes,
second
sir.
iteration, what will happen? The second element will become my first. Okay, now tell me your doubt. This will be my rest.
Okay, sir, I got it. Yeah.
Okay, 20 is already present, right?
Yes, sir.
Yeah, that's why. And if 20 is not present here, then the output will be different. Okay.
Okay, sir.
So yes, any other doubt? Anyone? Very good question. So you need to see both the procedures and recursion as well. Okay. Okay. What about question number 3? Same. What does the variable submission represent? Now tell me, what does it represent? Just look at the output. What does this represent? List of all submissions made by students sorted in ascending order of the time. List of all
No,
submissions
sir.
made by students sorted descending order of the time. Submission made by
No.
student ascending order of the time. List of last. Then what does
Last.
it represent?
Last
So
submission in ascending order of time.
yeah. So if you see the last submission in what order?
Ascending.
Ascending order.
Order of time. Yeah, order of time is what? Ascending. Yeah. So last submission, ascending order of time. So last submission, option C, right? Yeah, option C is the correct here, right? So once you know the output, you can easily solve question number 3. That's it. What about question number 4? Assume that reversal procedure reversal is which of the following state returns the list of first submissions made by the student sorted in ascending order of time. Tell me how to solve. What is the correct answer here? Which of the following statement returns the list of first submissions made by the student sorted in ascending order of time? And reverse is basically doing the reverse of that particular list. So if I simply reverse this particular list, so 20, 12, 12, so this will be in the descending order of the time, right? Descending order, yeah.
Yes, sir.
Descending order of the time if we reverse, and what we want.
Same gets up, but it should be in a reverse.
Yeah, the list of first submission made by the student sorted in ascending order of the time. So
fourth
first we need
option.
to reverse, and then again
First
not
we'll reverse the scores.
Yes.
Then we will
Reverse
reverse
in
the
score
output
and
also.
get.
first we'll reverse, then
D,
what we
sir.
are going
Yes,
to get.
sir.
Yeah.
Since
We are
if we
going to
reverse,
the
it will be in
get
descending order, then we need to again
Hmm.
reverse.
first
Reverse that,
submission
yeah.
in descending order. When we will reverse, then we will get in ascending.
So reverse of that score and get sub will give me this two output. This two output 20, 12. Yes, right?
Yes, sir. But
Yes,
in
sir.
But
descending order,
this
it will
will
be.
be, yeah, like this. 20 will be above and this will be down like this, right? And again, we are reversing that. So that will give me the required thing made by student in ascending order of time. Yes. Okay. So option D is correct here.
Sir, please repeat again this fourth one.
Yeah. So see, what we want to return the list of our first submissions made by the student sorted in ascending order of the time, right? So we have how many unique roll numbers? 12 and 20. So first submission made by them in the ascending order of the time, right? So output will be what? Ascending is this one, roll number 12 and 20. These two as output, right? First two element. So if we see here, for the first option, same we are going to get. So this is not a correct one. Here what we are doing, we are simply reversing this particular thing. Okay. So we are reversing this particular output. Which one? Here. So roll number 20 will go first, 12 down. So submission in the descending
Last
order.
submission in descending
Last
order.
submission in descending order. Yes, last submission descending order. But we don't want that. We want first submission of the ascending order. Again, if you use C, so what we are going to get? Reverse course. So we are
First
simply
submission,
reversing.
but in descending order.
Yeah, so first submission in descending order. And if I simply reverse that, then I'm going to get the ascending order, right? Yeah. So this is how this option D is correct. Okay. So
Okay.
please try to solve this. Okay, we can simply change here a statement and we can just put this there. Okay. So okay, so this is the question number 2, 3, 4 like this. What about 5? How many question?
11 questions.
Okay. So outcomes is a list of string that contains the information about outcomes of cricket matches played by India. Okay. So it's a list of string. Assume that each element in the list is either win or loss. For example, 5 matches. Okay, this is the output for outcomes. We call list of outcomes a blank slate if the number of wins is equals to the number of losses. So we'll call the list of outcomes blank slate when number of wins and number of losses are same. Blank slate is a procedure that accepts the outcomes as an input, returns true if blank slate and otherwise false. Right? Then choose the correct pseudo code here. Yeah, tell me, what do you understand by this particular statement? Yes.
If the
It
series
should
is a
return
draw, then
true
it is true or
when
otherwise
it is
false.
draw. One or loss is same.
Yeah. So if we have equal number of wins and loss in the list, then it is going to return that particular uh, outcome as an input, that particular list. If we don't have number of wins and loss, then it will going to return false, right? This is what it is. So let's take this procedure outcomes as an input. So here we have 3, 1, and 2 loss. So for this output should be false. But let's take even number. That will be win, loss, loss, win. One scenario W, 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 L. So in this case, that should return this output, and in the second case, it should return false. This is our requirement. Yes, is it correct?
Yes, sir.
Yes, sir, correct.
Now let's go option wise here. So numeric. What is this numeric? Okay, yeah,
Sir,
procedure.
can you explain it
Procedure
again?
call.
Procedure, yeah. So if numeric, so let's go to, okay, entire procedure is given to us, and here we need to fill the code here. So we are going to call this particular procedure. Let's go with the first option here. Taking L as the input, if length is 0, if there is no win or loss, then we are going to return 0. If last equals to 1, then again return numeric init of L plus 1, else return numeric init of L minus 1. So is this correct? Are we getting the outcomes?
Correct, sir.
Let's see. So we have this list WWLL. So we should get this outcome. And for this, let's say 3 Ws and 1 loss, we should get this false. So, but this is just the procedure for this numeric, not for a blank state, right? So let's go with the first case here. So length is 0, no, not true. Go for last of L is 1, no, go here. Return numeric int. So numeric of initial is what? Again, initial is except the last element. This one. So we are going to take again this as an input, not 0. Again, last is 1, no. Again, so input will be what? This one. Numeric WWL. Again, the input will be for this scenario going to return numeric WW here, right? Now at this case, what is the output? So not equals to 0. Last of L is 1. Yes, that is correct. Then we are going to return numeric of int. What is int? First element. So that will be this one. Okay, -1. So it should be a -1. Here it should be -1. And here the output of that will be what? Numeric W, right? So again, numeric
W plus 1.
plus 1. Again, we are going to call the function not equals to 0. Again, last of L is 1. So again, init will be empty. So here, this will be output will be what? 0 plus 1. Okay. So 1 plus 1, 2, 2 minus 1, 1, 1 minus 1, 0. So output of this will be 0. If the numeric outcomes is equals to 0, then it is going to return true, right? So this is what we want, right? If we have equal number
Yes.
of wins or loss, it should return true. You can simply change the order as well. If we just write like this, loss, W lost, sorry, let's say W here as well. So in that case, what will happen? So last of L will be like this here, and you can start with here again. Okay. So option A is correct here, right? You can try with this as well, whether it is returning false or not, right? So instead of going for 4, you can simply go for W and L and W as well. Maybe it should give the same answer, right? So option A is correct, and similarly, you need to proceed for option number B. Now tell me why B is not correct. What's the reason behind this?
So checking the last but removing the first element.
Yes, sir.
We are checking for the last and we are removing
First element.
first, right? So
We
anyway,
will
we
miss
cannot keep a
few
track of first element here, right? And here we are checking for the last and then we are removing the last element. Yes, correct.
Sir, in
What
option
about
B, we'll miss a few elements, right?
yes, yes. We are not going to compare those things, so not the correct answer. The remaining is what? Return rest. And here, yeah. So anyway, that is not correct. What about C?
Right, sir.
Correct.
First here, and then we are simply we are changing here instead of first last, instead of init rest. Rest, I guess, same thing. And here we are using the numeric of rest of -1. So rest, yeah, we are first and here last. Yeah, that is correct. Yeah, option C is correct. What about D? Why not correct?
Same, sir. Like option B,
Same thing.
it's
Yes,
missing
sir.
a few elements.
Checking first and
Yeah.
removing last.
So again, this is not a correct one. So option A and C are correct. Only difference is that in option A and C, we are simply checking for the first and the last element, and then here rest in the case of first and init in the case of last element. That's it, right? So you can take a sample like this and try to uh, apply this particular pseudocode there and see whether your requirement is get or not. So in this type of question, when you need to fill the code, try to go option wise and see whether it's satisfied or not. Okay. Any doubt in this
Sir,
question?
can you
Anyone?
explain it again?
Huh?
Can you explain it again? I have a problem.
Okay. Yes. What is your doubt?
The first one, I see the four pseudo-codes.
This one.
Procedure blank slates. At first,
Okay.
the procedure blank slate, I have a problem there. I don't.
Okay, so what we want to find out, see, this is a procedure blank slate. It absent the outcome as the input. It should return true if it is a blank slate. And what is this blank slate here? So you can see when number of wins and number of losses are equal, then we can say it should return true. Otherwise, it should return false. So for this particular thing, when number of wins and number of losses are same, it should return true. Otherwise, for this type of cases, it should return false, right? This is the output of this particular procedure. But here, if you see, if we take this as an input, then we are calling the one more procedure here, that is numeric, considering the same input. So we need to go and fill this code first. Now here what we are doing for this particular option, we are checking option wise here. So we are calling this particular procedure again, same list as an input here, and then we are trying to see whether last element is the one, then we are checking with the remaining one. So numeric init of 1 plus 1 like this, right? So here we are keeping a track of number of ones and number of losses, right? Like this. And if output is 0, if we have equal number of wins and equal number of losses, then output will be 0, and then it will return a true like this here. Okay. So try to take this two as an input and then do the pseudocode calculation. Okay. So this is for question number 5.
It is storing 1 for won and minus 1 for loss. So if they both are equal, then it's 0.
We are adding for 1 and then we are removing for loss. Yeah. So if we get 0, then equal number of wins are there or loss are there, right? So here you can just see the explanation. Okay, so 6th and 7th. Yes, 2N. Chess player are participating. Okay, are participating in the tournament. Each player is given a unique participant ID that is represented as a string, right? So the players' IDs are sorted, are stored in non-empty list. So IDs are stored in the players list in the descending order of their rating. First element in the list has the ID of a player with the highest rating, like this. Okay. So unique participant ID that represents as a string. Okay. The matches are scheduled as follows. Ith match is between ith player from the top and ith player from the bottom of the rating list. We wish to create a list called matches, which stores the sequence of matches starting with the first match, ending with the last match. Okay. Each match is represented by as a list of 2 players. First element of this ID of a player as an okay. Assume that no 2 player has the same rating. Okay, how many of you have solved this question?
Yes, sir, solved.
Okay. So what we need to do? Player list we got in the list, so in the descending order, that is correct. Then matches are scheduled as follows. Ith matches between ith player from the top, okay, and the ith player from the bottom of the rating list, okay. So we wish to create a list called called matches, which stores the sequence of matches. Okay, starting with the first match, ending with the last match. Each match is represented as a list of 2 players, first element of which is ID of the player, higher rating, okay, the lower rating. Okay, assume that no player has the same rating. Okay. So yeah, first you need to understand what is our given thing here, right? So when I say 2n, so whatever the n will be, say n equals to 5 or 6, it will be always even, right? So 2n will be the even. 2n chess player participating in the tournament, right? So match name is a recursive procedure that accepts player as an argument and returns matches. We need to select the correct procedure here. So let's say we have players. Okay, we have considered any list. Okay. Now what is players is having the participant ID. Let's say P1, P4, P5, P2, P3, like this. Okay. let's say we have 5 players, P1, P4, P5, P2, P3, but how? Descending order in their rating. If they has a rating is 10, 9, 7, 6, 4, right? This is the rating, and we just have the player ID inside this player list, right? The matches are scheduled as follow. Ith matches is between the ith player from the top and the ith player from the bottom. So from the top, from the bottom, right? So first player from the top, first player from the bottom, like this. But here we have PN, so let's say it is P6 as well, and rating is say 2, like this. Now we create a call matches, which store the sequence of matches starting with the first match and ending with the last match. Each match is represented by the list of 2 players. First element is the ID, higher rating, and second is the player of lower rating. Okay, so now let's solve the thing, match name. So we are taking this player as an input. If length of player is equals to 2, no, then we go to else block here. First of last. So first last is what? It will be a list of first and last player, right?
Yes,
So
sir. First
and
ID of
last player.
first and
So
last player.
P1, P6, right? Like this. P1, P6. Middle will be what? Init of rest of players. So first we are removing the last. First we are removing the first
First,
element and
then
then
last.
last element. So if we remove both the things, so remaining will be 4, 5, 2, 3. So 4, 5, 2, 3 will be taken as a middle element here. So P4, P5, P2, P3. Again, we are going to return the first name. What is first name? That is P1 plus
So
match name
first, last,
middle.
that one which we have created above.
First, last. Okay, sorry. Yeah, first, last. Yeah. So this entire thing, right? So P1, comma P6, right?
And that also enclosed within list.
Yeah. So it will be a list of list. Yes, correct. So if this is a list of lists like this, then what is the output of this? Again, match name middle. We have 4, not correct. Again, first, last, player and last. So P4 and P3, P4, 5, 2, 3, P4 and P3. Again, will be 5 and this 2. So again, we are calling this one. So here it will be the like this P4, P3 plus again that thing. Again, that will be only 2 is there. So length of player is 2. So we are going to return the players, remaining one. So that is P3 and 2. That is, sorry, P5 and P2. So is this the required thing correct here?
Correct, sir.
Which one was that? P1 and P6 was there, right? P1 and P6. So what we got, what we want at the end, we wish to create a match list which stores the sequence of matches, starting with the first match, ending with the last match. Yes, each match is represented by a list of 2 players. That is correct. The first element of ID is highest rating. Second is the element of the ID of player with the lowest rating, right? Assume that no 2 players have the same rating. Yeah. So this is what we got. We have stored the matches, first match and ending match like this, and each element represents the first with the higher ID and second with the lowest ID like this. Okay, so if you see this P1 and 6, 10 and 2, then we have 9 and 4, then we have 7 and 6 like this. Okay, so this should be the correct one. A, yeah, this was correct. Whatever we got, right? Any doubt here, anyone? See, you need to solve this question by your own. Okay, unless you solve this question by your own, you are not able to understand this type of question, right? I am showing this here how to solve this, so that's why you are understanding. But if you again try to solve by your own same question, you may you may face, you may come with more doubts, right? So please try to solve this question again. Yes.
So in this one, this is firstly making separations of the first and last. Init and rest will remove those who are already been taken in first and last. After
Yes.
this, match the middle will again call this. So this will just break and make the whole list.
Yes, like this. Yeah. So first we are going to take these two, this two, then this two, and then middle remaining. We have two elements. So here we have 6 players. Same thing it may happen in the case of 10 player as well. So this two, then this two, then this two, and the remaining two will be taken care like this. Okay. In the case of 8 player. So anyway, the ID of the first player will be always higher than the second player here, right? Higher rating, and ID will be the lower rating. And the match number will be what? First match is between the first player from the top and first player from the bottom. Do we get that? Here you can see, right? So first player from the top, first player from the bottom, we got the match number 1. Second match number is what? Second player from the top, second player from the bottom, right? Third is what? Third player from the top, third from the bottom, right? This is what we got. That is why it is list of list. Match 1,
Sir.
match 2, match 3.
Sir,
Huh?
I have a doubt in the return syntax. What's actually
Yes. What is your doubt?
I clear all the syntax, but I have a
Huh.
doubt in the return syntax, line number 8, sir.
Here. Okay.
How actually it works?
Yeah. So the first last is basically this one, and this is list, right? So
Yes,
output
sir.
of this will be what? P1, sorry, P1 and P6, right? So P1 and P6, for example. Now what we are doing here, if you observe, we have one more bracket here. The output is list P1 and P6 like this. But here also we have one more bracket, so that will be a list of list. Plus, the output of this will be what? Again, if we call this particular procedure, again we'll go to get the same thing, that is list of list. Like this, let's say P2 and P4. Again, if you call this, so at the last, so this will happen till we have 2 elements remaining, right? So here anyway we are going to get list of list. But what happened here? Here also what? Players is basically a list only, last 2 player remaining. Again, you are putting into a bracket, so again it will be a list of list like this. Okay. So at the last, what we are going to get? We are going to get entire list having P1, P6. Then we have, let's say P2, P4, and let's say we have this P3, P5 like this. Okay, in this way. So this is a list of list. This represent the match number. First, second, third. 3 matches. In the first match, first player from the top, first player from the bottom. Second match number, second player from the top, second from the bottom. Third match number, third from top, third from the bottom, like this. The output will be like this. Okay.
Okay, sir.
And after this matches, if we assume that high rating one wins, then we won't be able to make matches for the next round.
Sorry, can you repeat?
After this first round of matches that we have decided, if we assume that the higher rating person gets he wants, then for the 3 elements this procedure won't work.
No, why? See, we are taking these players as an input here, right? Already defined the players here in the descending order. So order is fixed of their rating, right? Order is fixed, then it is not possible that someone will get the higher order after that. Okay, so
Yeah,
order is
but
fixed here.
for the even this is working, but for the odd number of elements this won't work now.
Odd number of element, that's why we have mentioned
2
2n
chess
here.
players.
Okay, 2 n chess players.
Okay.
So whatever the n value will be there, it always be even, right?
Okay.
Yeah. Okay, and similarly, if we see for option number B, what's wrong with this? Everything is good. Here also list of list, but here only list. So we cannot append the 2 different data type. It's a list of list. It is a list, right? So option B is not correct. I think rest is same. Yeah, rest is same. What about option number C? Here we are returning the empty list
Correct.
here. That is okay if we don't have a clear into that. So what we are doing here in the option A and option C, what's the difference? Remaining last 2 players were already considering that into a final output. But here we are considering in the second statement as well here. So same thing, middle will be 2. So output will be this, and here we will get the empty, and empty will be what? 0. So we are going to get the empty list. So this is also correct. Okay. Only difference is that here, when this condition gets satisfied, when we have just 2 players remaining, we are directly returning that remaining players list. But here what is happening? We are also considering those 2 players, and again we are putting into first and last, and then we are removing. Now this becomes empty. And now when it is empty, we are calling a empty list here, right? So this is also correct. Because we have 0 player in that list.
Sir,
Any
why
doubt in
why not
why?
option?
D?
No, sir, B.
Yeah. So B, if you see here, we have players. We don't have list here, right? This is a list of list, but output will is only player, only list, right? So we cannot append. Yeah. And D also, if you see here,
At last, empty list will get
what
appended.
is, yeah. If there are no players, then players is what? This one,
Empty list. It will return
empty
list.
list. Yeah.
List within list it will return, sir. So empty list will be get appended at last.
The empty list will get appended. Yeah. And here only list. Yeah. So players, yeah, we are checking if there are no players. So same thing, empty list will be there, right? And remaining is same. Yeah. So option A and option C is, oh, we have one more question here. Okay. Question 7 number is also linked to that. Okay. So he can see match name is a non-recursive procedure that accepts the player as an argument and returns matches. So the correct implementation of the procedure. Okay. Match them. And here what is the question? Here also same thing, right?
Same question.
Okay, same question. Okay. Yeah. It's a non-recursive thing, right? Okay. We don't have matches. Match them again. It's a non-recursive procedure, and here it was the recursion, using recursion. So same thing you can consider here. This one is easy, right? Let's take same thing for 5. So 10, 8, 6, 5. So what about option number A? Tell me, this one is easier. There is no recursion. Tell me, what about option number A?
Sir, wrong, sir.
Why it is wrong?
Sir, the ranking first should be highest, and it's taking the lowest ranking for the first match. Last
Yeah.
of player, comma first of player. It should have been first of player, comma last of player, because they are
Last
arranged
of
in
yeah.
descending order.
Yeah. So we want P1, P5, but it is giving me P5, P1, right?
Yes, sir. Yes, sir.
So again, not correct. What about B? P1,
B is
P5
correct.
is okay. So match list greater than matches empty list. We are going to append that. This will be rest of init of players. So are we removing the both? Yeah, first and last we are removing. Then again, we are going for the while loop, and again we are returning. Yeah. So option B is correct here, right? Yeah, option number B. What about C? Why not correct?
Sir, equal to 0 is also is considering. It will throw an error because first of player we cannot determine when it is empty.
Okay, can you repeat? If it when it is empty, what will happen?
Sir, players is empty. So first and last on the empty list will give an error. We can only use init and rest on empty list.
Right, right. So when it will be empty, that will be what? Equals to 0. No elements are there. This condition will become true. Again, first and last player, we don't have anything, right? So not a valid one. What about D?
Sir, D is also wrong.
Here, rest of players, right? So that is
Rest of
fine.
init of players.
Yeah, we want rest of init of players. So only option A is correct here. Okay. Anyone, any doubt in this question?
So in that equal to 0, this last and first won't give anything if they have got the empty list then.
No, it's an empty list, right? So we cannot get any first or last element from that, right?
So do they give error if they don't find anything?
Yes.
Undefined, they will give error.
Yeah.
It will be kind of empty list and empty list. Oh,
No.
okay.
Invalid thing, right? First top layer, last top layer, again, we cannot get from this, okay?
Okay.
Because we are taking the element from this, but there is no element. We are not removing anything from that, right?
Sir, how
Okay.
option B is wrong?
Option B is correct, no? Option B is
Option B
correct.
is correct.
A is wrong.
Sir, how option A is wrong? Sir,
So here,
I
last and
it was
first top
same.
layer. Huh?
Sir, but if the last player matches with the first player or the first player matches with the last player, it's the same thing.
No, we want in specific order. So descending order, right? The first player should
Okay.
be whatever the first element should have higher rating. That is not happening here, right?
Okay, sir.
So rating must be higher than the first, second element. Yeah.
So that particular code will run in infinite times, no? Because every time the condition gets true, if the statement don't makes any error, then
This one.
it will go infinite, infinite, infinite. Yeah.
Yeah, this will go to infinite because equal to 0. Yeah, it will keep continuing. It will not return anything. Yeah, that is also correct. Yeah.
Okay, sir.
Because equal to 0 is there, no elements are there, and it will go to infinite loop. Yeah. Now, question number 8 and 11. Okay. What is the question? Okay, let's see. Consider the following graph with 6 nodes, 6 by 6 matrix corresponding to this graph. Assume it already computed. So assume we are already computing the 6 by 6 matrix here. The following pseudocode graph is a matrix. Okay, graph is a matrix. Parents is a dictionary and sequence is the list. Okay. Now procedure DFS graph parent sequence. So sequence is a list, parent is a dictionary, and graph is a matrix. Okay, I is what element, okay, given to us. Answer the question 8 to okay. In all the question, S represent a list, P represent dictionary, S represent list, P represent dictionary, while A and B represent matrix. Okay. So what will be the value of S after executing the following pseudocode? P S P0. So DFS taking A as a matrix as an input, P is empty dictionary, S is empty list, and 0 is the I here. So what will be the output? S? Yes, anyone? So this is 0, this is empty, this is list, and graph is what entire this thing matrix. So adjacency matrix of this. So sequence equals to sequence plus plus I. So initially sequence is what? It is a list and it is empty list plus plus I. So we are going to append 0 in that, 0 only, right? Yeah.
Sir,
For huh?
sorry to disturb, but then if we do create a n by n matrix out of this, and if we are saying that the value of 0 ij is -1, it means that uh, all edges are coming inside this. So 0 is not a parent of anybody, to my understanding.
Where it is -1 here?
The first question is written P0, the
Here.
value of P0 is -1.
Yeah, okay. So is a parent dictionary.
And this is a directed graph.
No, undirected graph. We don't have direction here.
But then if this is I mean if it means to be a parent, so then if 0 is the father of 1, let's say 1 cannot be father of 0. If parent has to mean in its traditional sense. If it is something else, then it is something different. But then, and otherwise also, how will the value be -1 then?
If
That
we,
is why I was asking that if you have a incoming incoming vertex, will it be amounting to 0 or -1? Now, in this case, it makes sense to have a -1. But if it is you all have an edge from 0 to 1 and 0 to 3, let's say.
yeah. So here, if we first calculate the matrix here, so in 0 to 1, 1 to 0, it will be 1, 1, right? But we are saying P of 0 is -1. Okay, let's discuss this question. Let's see what we are getting. Okay.
Yes, sir.
Because here, yeah, P of 0 is given as -1. So this is the given thing. Let's see. So here we got 0. So sequence will be what? I, that is 0. For each chain columns of graph, columns of graph will be what? List of this 0, 1, 2, 3, 4, 5, right? For J, what is the value of I? 0. So we are want to check from 0 where I can go, that is equals to 1. From 0, 1 to 3. 0 to 0? No. 0 to 1, when J equals to 1? Yes, there is an edge,
Yes,
right?
sir.
Now let's see. And not is there. What is parent is initially empty. Whether J is in the parent? No. This is false. Not of false will be true. Both are true. If both are true, what we are doing? Parents of J, what is J? 1, right?
1.
So parents of 1 is equals to I, that is 0. So P inside the dictionary, which is initially empty, right? We are adding 1, corresponding value 0, right?
Sir, one element we are adding before sending it as argument, right? 0 as key and value as -1.
0, yeah.
Because
So
we are starting from 0.
yeah, so already we have that. So 0 and -1, right?
Yes, sir.
Now this is not empty. 0 and -1 is there. But if you see, 1 is not present inside the parent, right? So anyway, this is false, and false not of false will be true. This will be true. Now what we are doing for J equals to 1, I. So we're adding Y equals to 0 here, right?
Yeah.
Now parents sequence, again we are calling the same function here, but sequence is, oh sorry, J is 1, sequence is what? This one 0. So let me write it down. We need to keep a track of everything. So sequence S will be what? 0. P will be what? 0, -1, 1, 0, right? And graph is that particular graph. Okay, so we have taken this, and now J is basically 1. Again, we are calling this particular procedure. Let's see what is happening here. So 1, again we are going to append 1 here. So sequence will become 0, 1, right?
Yes, sir.
Now let's see for J, but it is 1 in columns of graph 0, 1, 2, 3. So starting from 0, so here it will become 1. Now J is this one, right? So yeah. Now whether 1 to 0 can we go?
Yes, sir, we can go.
1 to 0 we can go. But what about this condition? Tell me. Now J is 0 here. 0 is present in the parent dictionary.
Yes, sir.
That is false. And sorry, that is true, right? Not of true will be false. So entire thing is false. Go for next one. J equals to 1, 1, 1. No, not this is not true. Go for next one. But from 1, I can go to 2 and 4, right?
2.
I can go to 2. Whether 2 is present inside the parent? No.
No.
So what we are going to do? We are going to add 2. Then the value will be what? 1.
1.
Right? Again, we are calling this particular function here like this. Okay. And remember, we have not done all the for thing here. We are still when J equals to 2. And before that, we are still in the for loop where J equals to 1 for 0, right?
Yes, sir.
So we have multiple for loop and we need to complete each for loop to backtrack. Okay? It's not like that we can backtrack directly. If I come back it again here, again I need to go through for all the elements like this. Okay. Now this is what we are going to get. Okay. So what we want to get? Output of yes, and S will be what? output of this one, parent and sequence. Sequence will be this one. Okay, so 0, 1. Next element is what? Which one was that?
2.
For which value of j? Yeah, 2, right? So for value of j, 2. So 2 we are going to use. Again, we are going to add a 2 here. Now what about j equals to 2? Uh,
Condition gets true so that the if
Dictionary,
condition
right?
terminates.
from 2 where I can go? From 2 I can not go to 0, not for 1. I can go to 1 again. So j equals to 1 again true, but 1 is in the
Sir,
parent.
2 you didn't update in the dictionary beforehand. You went to 1 to 2, right?
So 2, 1 na?
No,
For
sir,
2.
from 0 to 1 you went. So you updated 1 is to 0. Then 1 to 2 you went. So you need to update, right? 2 is to 1.
1 to 2. 2 is to 1 here na? In parents.
Yes, sir. Yes, sir.
Yeah. You are considering like this one. Yeah.
Okay, okay.
So here, yeah. Now for what value of 2? For the first one again, but 1 is in the parent. Go for a next 2. 2 to 2. No. Go for next 3. Yeah, I can go to 3 like this. So j will be 3 is 1. Yes, age is there, but 3 is not present. That is true. So here it will be 3 and that will be
It's
what?
to 2.
2.
2.
And here we have added, right? 2. Yeah. Now again, what is the value of j now? For which value of j we got 3, right?
Yes.
What happened? Yeah. 3 here. Okay, so again, call this particular procedure. Again, S will be what? 0, 1, 2, 3 like this. Is this visible what I'm writing?
Yes, sir. Visible.
Okay. 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 So again, 3. Again, we need to do same thing again for I3. Again, for this J3. Again, from 3 where I can go? I can go to 0. But 0
Yeah.
already present. Next 1. No. 2. 2 already present. 3. Not 3. 4. No. 5. No. So
No.
for
No.
j equals to 3. Sorry, for I equals to 3. What is happening here? For I equals to 3. This condition is not becoming true. Right?
Yes, sir.
Then we are returning this particular thing for that particular iteration here. Right? So output for this will be this one like this. And again for the previous iteration we need to go. But if you observe 0, 1, 2, 3. Okay, 4 and 5 is remaining.
Sir, we will go back to that 2, right?
2 and then from 1 and from 1 to I will get 4. No, from 2 we will get to 5
2,
first.
we will go 5.
Yeah, so that will be added 5 and then remaining will be 4. But for 5, what will be the element?
5 is
2.
to 2.
Yeah, and for 4, 1.
Yes, sir.
So let's see. S means what? Sequence. 0, 1, 2, 3, 5, 4. 0, 1, 2, 3, 5, 4. Yes, that is correct. Okay. So see, we have not stopped it. We know what this procedure is doing. That's why we have directly gone to the conclusion because of a DFS thing. Same is applying here, right? But if you see for the previous iteration, when the value was j equals to 3, we stopped there. And if we output of this one, but if we continue to go that, again, the value of that will get changed for to j2, 4, and 5. Anyway, there is no age. Then again, we'll backtrack. Again, we'll go for a here. Again, we'll do again. Then from a 2 in that particular for loop, I will get for this value this particular condition true. Are you getting my point? What I'm saying? So we are backtracking, but still the for loop is going on for the individual node, right? So that's how we are going to node 5. Sorry, from 2. Okay. So
So
see,
this P
yes,
this P is storing child to parent relations in a dictionary format.
this P is storing, child to parent. Yes, we can say
Sir,
4, 1. Yes, child to parent, correct. Yeah.
sir, from node 1, there are two options. One
Mhm.
is 2 or 4. How we determine that we want to go first 2 and then 4?
See, columns of graph, it will always start with the list 0, 1, 2, 3, 4, 5 like this, right? So
Okay,
j
okay,
equals
sir.
to 0, j
Understand.
equals to 1, 2 like this. First we are going for 2 like this.
Yes, sir.
And see what happened here, what I said, when 3 equals to 2, we return this. But it is the output when j equals to 3 for the initial, for the previous one. When I go back, again j equals to 4, no h, j equals to 5, no h, then backtrack toward 2. This was true when j equals to 1. Again, when j equals to 2, we need to go, not true. Now from 2, 3, already there. From 2, 4, I cannot go. Again, when j equals to 5, now that time this condition will become true and 5 is not present. Then again we are calling here, okay? So we are backtracking via for loop here. Okay.
Sir,
So
Then, sir,
huh?
the basic assumption under this solution is that you can go from 0 to 1 or 0 to 3 or 1 to 4 or 1 to 2. But then the first condition that they have said is P0 is 1, minus 1 rather. So what I'm not understanding is if it is, see, it has to be 1. If you
No,
have to
see,
go from,
if you see what this P is storing, this is a child, and this child don't have any parent. This is what we are getting here for 1, 0. So 1 is a children, 0 is the parent. Same here you can see 5 is the children, 2 is the parent, right?
so
Yeah.
For 0
So
we
if
don't
we
have any parent, right? We are starting from 0.
yeah,
That's why it is minus 1.
yeah, if we assign 1 as the parent for 0, then this whole won't work.
But then but this then again means that see if value of 0, if we draw an n by n matrix, so it means that in the row of 0, wherever you have 1 or 3 coming up, the answer, the value would be minus 1, right?
No. Here we are initially the P is dictionary is empty, and we are adding that element inside that particular dictionary here, right? We are talking about that particular dictionary. We have not updated the graph G. So P is initially empty dictionary, and then we are adding a key value pair here, okay, in that dictionary for this dictionary. Okay.
sir,
Huh?
can you go to the pseudocode?
Yes.
Sir, here when we were iterating to 3, we didn't get any value. Then we
Sorry,
backtracked.
3, right?
Yes, sir. 3.
Uh-huh.
We didn't get any value. Then we backtracked to this 2, where I was 2.
Hmm.
I was
Yes.
2, and we were iterating to the third column when we came to 3. So now we will start the j value from 4, right? When we went back to I is equal
Yeah.
to 2, where we left, we will start from there only.
No, no. See, when j equals to 3, this got true, right?
Yes, sir. True. And we went to third node. We explored the node 3, but we got nothing on 3.
Hmm.
Then
Yeah.
we will come back to where we have left, sir. Then I was 2 and j we were iterating through the third column index. So now we will iterate through I2, then j4 and 5. Then we will go to that node 5.
Yes. Yeah. If we complete this for all the value of j, then we go to 2. And but for that, if you observe, we were still when the value of j equals to 1, right? Sorry, not 1.
3.
Yeah, 3. Yeah.
3.
So 3, yeah. When the value of j equals to 3, then the next iteration value of j will get to 4 and then 5. But when j is
Yes, sir.
equals to
Yes.
4, we don't have 8.
Anything. It will not
Go
get
for the
correct.
next iteration, j equals to 5. Then we have 8. Okay. And 5 is not
And
in the
sir, for
dictionary.
3, when we returned this parents and sequence, it returned the same thing, just the sequence it appended 3, but parents remains the same,
Yeah,
because for
parents remain
3
the
we,
same. Yeah.
and it got returned in line 6 where we call this DFS call.
Yes, yes. And that
Okay,
was
sir.
the output of previous iteration what we have done, right?
Okay, sir. Okay, sir.
Yeah. So that's what I said. What we have done, that is correct up till now. But after that, you need to think we have not completed all the iteration for loop for this 0, 1, 2. So that's why we need to again backtrack and complete all the for loop. And then at the last, it will return this one. But once you get all the p values, once all the node inside the p dictionary, so anyway, this will not become true, right? This condition.
Yes.
Yeah.
Yes,
So you can think like that. So output of this will be option number C here. And what is the next? What will the value of node here? See, we are starting from node 0, that's why -1, and here we have just 5, right? So we are not updating here. We are saying P is initially empty, and then we are adding for that particular key, we are adding that value here, right? Now tell me the answer for this one. Same thing I think we are doing here, and node is what? Keys of P. So keys of P is the list of the keys
all
here.
the nodes
Yeah, all the nodes. But we need to
visited from 5.
check the sequence here. Sequence will be different in the dictionary, right? So here you can say P initially empty, but at line number 3, that will be 5 minus 1, right?
Yes, sir. 5 minus 2.
Now again we are calling this same graph, same P. This will be P, S will be empty, and 5. Now it should start with 5, so 5, 5, 5. Okay, so let's see what is the next element we have. Let's see why we cannot determine. J is 5 and P was what? 5 minus 1, right? So again, in the sequence, what we are going to add? We are going to add 5 here for each J in columns of graph. Now, I is 5. From 5, where I can go?
2.
2, right? So from 5, I can go to 2. For J equals to, this will get true. Again, 2 is not present inside the parent. So we are going to add 2 and then 5. So we are going to add 2 and 5. So this will get 2 comma 5. Then what is the next thing here? Value of J is what? 2. Sequence is this, parent is this, graph is this. Now what will happen when I equals to 2?
We'll append the 2 to the sequence.
Yeah, we'll append that 2 to sequence, and from 2 where I can go?
2, 1.
I will be 2, and from 0, no, from 1, yeah. So 1 is correct, 1 is not in the thing. So for this 1 and value what? Sorry. J is 1 and I is 2. So 1 and 2. So this will be 1 and 2. Yeah, if you understand previous code, now I'm directly writing it here, okay? So 2, 5, 1 and 2, like this. Now, what is J? 1, right?
1.
1, 1. Now from 1 where I can go? 1.
0.
I can go to 2 as well. I can go to 4 as well. But 2 already present.
Columns.
4 we cannot go. 4 we can go, but after 0. So first 0. So we can add 0, right? And that will be what? 0 and 1. So 0 and 1. Now this will be a 0. Again 0. Now from 0 where I can go?
3, 3, sir.
0. From 0 we can go to 3. Yeah, no, we can go to 1, right? Initially, but 1 is
Yes,
already
sir.
in the
Initially
dictionary.
we can go, but 1
Yeah.
is in the keys.
Yeah. So
1
from
is
0 we can go to 3. So this will be 3, 1. So we are going to add a 3, 1, 5, 2, 0, 1, 3. Okay. Now this will be what? J equals to what?
3.
3. Now what will happen for this 3? Appending.
Yes, sir. Append in sequence.
Yeah.
And then we
From
can
3
go nowhere.
2. No. 2 is
2.
already there in
Yes,
the,
sir.
yeah. 0 is already present. So for all the 3 we cannot go. Then we'll exit the for loop. We'll return this one. And again we backtrack to a previous node was which one? 0, right?
0.
From 0 we visited 3, we can go to 1, but already there. We cannot go to any other thing. That is
Backtrack
correct,
to
but
1.
yeah,
Yes, sir.
backtrack to
Correct.
1. Then again 1, where we can go?
4. 4.
4. 4 is remaining, right?
Yes, sir.
So for 4, So I is basically 1 and j is basically 4, and 4 is not a parent here. So 4 we are going to add for 1. So 4 1. Now again here j is 1. So again we are calling this 1. So 1 is already present, right? So we are
Yes, sir.
backtracking, then 2 is present. Everything is the present, then why we cannot determine?
Sir, keys of nodes, we don't know the order.
Uh,
Keys of P, we don't know in which order the keys will be present.
Keys of P will be this, na? 5, then 2, then 1, 0, 3, 4.
Yes, sir, it will give that, but in which order it will give, we don't know that. If you'll go and see the option,
Uh,
we cannot determine, sir, because we don't know, because keys function gives the keys, but in which order we don't know that.
okay, so yeah, this is what we are getting, right? If a node 5 happen in the sequence, but key is not necessarily above list. All that we can say, every element in the above list will represent the keys of P and vice versa, the exact order in which keys of P. Yeah, then option will be in all the three, no? 5, 2, 3. Okay, yeah. We cannot determine. So order we cannot determine. Yeah. The value of order executing. Yeah, we can say option D is correct here. Sequence is not present.
Sir, if it asks the sequence, then your option would have been correct. Or nodes, if they have not given keys, just they have given, then we cannot determine only because we cannot extract the keys without keys
Yeah.
function.
If they ask for sequence, then that will be correct, right? Yeah. That
Yes,
is a
sir.
sequence. Yeah. Okay. Yeah. But you understand how the pseudocode is working for that thing I equals to 5, right?
Yes,
Okay.
sir, got it.
What about question 10? What we are doing here? Assume that is a procedure that accepts a list of integers as an input, return a sorted list in ascending order. Okay, procedure that accepts a list of integers as an input, a sorted list. If okay, so start 0 and 5. Which of the following are true at the end of execution of pseudocode? So P this S list, P of start. So what is this start here?
Any nodes, sir.
Okay, so which of the following statement is true? Execution. So start. What we want to find out? Nodes or yes, right? So if we start from sorted list, if 0 less than 5, the true at the end of execution. So let's say we have a returns abstract integers between 0 and 5. So 0, 2, 3, 4, 5, 1 like this, but in the ascending order like this we want. Okay, so we have called this DFS start any element, start with 0, then -1. If you start with 0, then same we'll get what we got in the question
Yes,
number
sir.
8. So 0, 1, 2, 3, 5, 4. But here, okay, sort is a function, right?
Yes, sir. Sort is a
Yeah,
function.
sort is a function, then same anyway, we'll get that in the sequence. That what sequence is here. So same question. No? So S is basically this one. It is correct. Nodes is what sort of keys? Keys, again, if you are sorting, again, you will get the same thing. Then what is the thing here? B is not correct. Why?
That sequence depend on the starting node, right? We
We are
cannot
not sorting
generalize
this.
it.
We are not sorting this. We are sorting the nodes. Sorry. Yeah, we are sorting the nodes. Nodes will be correct. Sequence will be that one what we got in question number this one 0, 1, 2, 3, 5, 4. Okay. So this is not a correct one. Yeah. Option B is not correct. We're applying sort function to only nodes here. Yeah. The values of nodes independent of start. Yes, that is also correct. Doesn't matter. Anyway, we're applying the sort function. So it will get like this. Okay. And what about D? Value of S independent of the start.
No, sir, it is
No,
dependent
it depends, right?
from
From
where
which
we
node we
start.
are starting. Yeah. E graph is connected. Yeah, we can say that if
Correct,
we are
sir.
covering all the nodes, then we can say connected. Okay. So anyway, A, C is the correct answer here. Simple question, just we need to understand how this pseudocode is working. Okay. Question number 11, the following pseudocode. Again, same thing. We are starting from this one. Again, then we are creating a matrix for each in keys of P. Okay. So here we are starting from 3. V is a matrix for the following graph. Okay. So V is the create matrix 6, 6 for each keys of P's, right? So what will the keys of P's here? List of that particular thing, right?
Yes, sir.
So order doesn't matter. So any we can write
0, 1, 2, 3,
1,
4,
2,
5.
3, 5, 4 like this. So if I is not equals to 3, okay, what we are doing, parents equals to, let's say 0, so not equal to 3, P of 0 is what? P. And yeah, but we need to keep a track of that particular node, right? So again, we need to apply that thing for finding out the dictionary when it is equals to 3 and minus 1. Tell me what will be the dictionary here for P.
Sir, can you once explain that code? I am unable to get, sir.
Which code?
Yes, sir. This one, what we are doing. Parent is
No.
equal to P of I.
So first what we are trying, this initially empty, P in the that particular dictionary, we are putting this key, this as a value, and then
Okay,
again we
sir.
are calling this particular function, right? So we will
Yes,
keep
sir. Yeah.
doing this until we get the output. So we should get this entire P first. Once we get the entire P, then we are creating a B matrix 6 by 6, and in the keys of P will be what? This 0, 1, 2, 3, 4, 5. But we should
Yes.
have the P to get this particular value, right?
Okay, sir.
Yeah, and then B of parents of I will be equals to 1. So we are starting
So
from 3.
let's compute the piece.
3, do we have started with the 0? Yeah. Now quickly tell me how this pseudocode will work if we start from 3 now. We already
Sir,
solved
just
this
show the
question
graph.
2
We
times.
can see the graph and tell.
Correct.
Sir, 3, 2, 2, we will go first.
3 and minus 1, right? So from 3 where I can go? 0.
2, 0, sir. Sorry, 0, 0.
Right. So that will be 3 and 0 like this. Can I write like this? Sorry.
No, sir. 0 is to 3.
0, 3. Yeah. 0 and 3.
Then
Right.
1 is to 0.
Then 1, 0. Then from 1?
2 is to 1.
1. Then from 2?
3
3
we
is already
cannot go.
present, right? Yeah.
Yes, sir. So
5.
we'll go to 5.
Yeah.
5
So
is to
3, 0, 1, 2. 4 is remaining, right?
Yes, sir.
So we'll
So
backtrack, 4, 1, right?
4 is to 1. Yes, sir.
This is what we got. So 3, 1, 0. So let me write it down here, and then we can simply do that. That is easier one. So what we got? P 3 minus 1, then
Minus. Then 0. 0 is to 3.
0, 3, 1, 0, 2, 1. 0, 3, 1, 0, 2, 1. So 0, 3, 1, 0, 2, 1, 5, 2, 4, 1. 5, 2, 4, 1. That's it. We got this P. Now we are creating keys of will be 0, 1, 2, 3. When I is equals to 0, not equal to 3, correct? Parent will be what? P of 0. What is P of 0 then? 3, right?
Yes, sir.
P of 0, that is 3. Now for this, the matrix B, parent is 3. What is I? 0, right? That is 1. So we have age from 3 to 0. So let's see which option. 3 to not correct. 3, 0. B can be possible. C can be possible. 0 to 3 not correct. Only B and C can be possible. Okay. Are you getting my point? Why I'm saying B and C is possible? Why not A and D?
Sir, can you
Yes, sir.
show that?
It's
Huh?
reversing kind of, na? It is child to parent. It's making parent to child.
Yeah. How we explore the DFS? Yeah. Parent
Sir,
to child.
here we are creating that parent again. Parent is
No.
equal to P of I.
Parent equals to P of I. So that is what value
So,
of 0, right? So P of 0 is what? 3 here.
okay, we are extracting the value. Okay, sir. Okay, sir.
Yeah. P we already got na from the
Yes,
this
sir. Yes, sir.
particular
We
case.
got it.
Yeah.
Got it.
So
Got it.
3 0. So 3 0 we have 1. Okay. So there should be H from 3 to 0. So option A and D eliminated, B and C is remaining. Now go for next iteration. I is 1. Parent is I. Again, I is not 1 is not equal to 3. True. What about P of 1? 0 here, right?
Yes, sir.
So 0 and I is what 1? So 0 to 1 we have 1. So 3 0. 0 ke baad 1. So 3 0 1. Okay. B is still there. What about C? C is also still there, right? Now similarly in this way you can simply go fast. Again, next will be 2. For 2 that will be what? Parent will be what? 1. So that will be 1 2. We're simply reversing this. This will be 3 0 0 1 1 2 2 5 1 4 like this. Okay.
Yes, sir.
And minus 1 3. So it means that 3 is the starting node. So 3 2 0 0 2 1 1 2 2 2 2 again, sorry, 2 2 5 and 1 2 4 as well, right? If you see here. Now let's see the graph. 3 0 1 2 2 1 2 4. Yes, option B is correct here. Yeah, option number B. Okay. So that's it.
Sir,
Okay.
first in this iteration,
Mhm.
we can start without not equal to 3. Then we can take first 0 also, no, sir? It's not mandatory to take 3 at first, no?
No, no, yeah. We are started from 0 1 2 3. Here keys of P will not give me anything, right? So that
But why
sequence.
you are telling we are starting from 3, sir? We can start from any node, right?
No, no. Okay. When it is not equals to 3, then we are doing this, right?
Yes,
So
sir.
we have set 0. Let's start with anything. Let's say 5. Okay.
Okay, sir.
5 is not equals to 3. Parent is 5. Sorry, this will be P of 5 is what? This is our P. P of 5 is what? 2. So this will be
2.
2. So 5 and 2. So there's H from 5 to 2, right?
Yes, sir.
Again, if we go and if we found out when 2, so this will be again when
So
I
this
is equals to 2.
matrix B, sir, we are just
Huh?
creating parent to child relation and we will give that value only one, where we can parent and child. Then we'll
Yeah.
in matrix we'll give that. Then in matrix only 5 values will be one in each row.
In
Oh,
that
sorry,
matrix.
6.
Yeah. So whatever the number of ages we have, that will be 6. So 1, 2, 3, 4, 5 only, right? 1,
1,
2,
2,
3,
3,
4,
4, 5, 6. No, sir. 1, 2, 3, 4. Okay,
5
sir.
only.
5, 5.
Yeah.
Okay, sir.
Yeah. So even if you start from anything 5, but if you go to when I equals to 2, so what is 2 here? 1. So this is 2 and 1. So 2 to 1. So again 2 to 1. Wait, parent is 1. So parent is 1, I is 2. So we can say there is H from 1 to 2. So is H from 1 to 2 like this, right?
Okay,
Like
sir.
this.
Okay. So
Yeah.
there will be 5 edges. When we will create this matrix B, only 5, 1 will be 1 in each row.
Yes. Yes. Yes.
Okay, sir.
So okay. So that's it from this session. So please try to solve this assignment again. Okay. We have solved this, but if you have not solved by your own, so try to solve. You may get more doubt, more questions, right? Okay, so like next week we have 3 sessions. So when we have planned sessions, let me check. One we have as usual on Monday, one we have on Friday, one we have on Thursday. Okay, so Monday, Thursday, Friday, 3 sessions. Monday week 1 to 4, Thursday week 5 to 8, Friday 8 to 11. This is timing is same 6 to 8. We'll update in the calendar by tomorrow. Okay.
Excuse me.
Okay, sir.
Huh?
Hello.
Yes, sir.
Actually, CTA revision session,
Hmm?
uh,
Yes, city revision session only. Monday, Thursday, Friday.
Not any question answer.
No, in revision session, you can ask if you have any doubt. Okay.
Okay.
Revision
Can you
means what?
please
We'll discuss few concept and then we'll discuss few question.
can you please
Okay.
upload this assignment, rather the
Yes, sir. Please
graded
upload the
assignment?
solution of this
Solution. Okay.
week
We
11
need to see this
graded, sir.
last question. I'm still,
Detailed solutions, sir. That one, please upload.
This PDF only, no, what I have shown.
Yeah,
Yes, sir.
yeah.
That PDF only.
Yeah. Okay. Just a
Yeah,
second.
this was supposed to mean the value, the initial start value. But I'll go through the assignment. I'm still not able to, digest that.
So you are still in that P of 0, Y minus 1, right?
Yeah,
No,
I
no.
need
That
to
is for
understand.
that particular case. We are assuming that 0 don't have any parent.
That is what, but then in that case, the entire movement, we are freely moving from one node to the other node, saying that the movement is not restricted. But you,
Today's session
the
end, no,
moment,
sir?
Session
huh?
is end. Yeah.
Yeah, actually,
The moment, so
Huh.
sorry, the
mathematics
moment I
session start.
say that this is a
I-
directed graph, then my movement will not take place in that fashion.
No,
If
That
I
is not a
can,
directed graph, na.
Amit, actually, we are not changing anything inside the matrix or the graph because we are storing in dictionary. So we need a value for that particular key. Without value, we cannot make the dictionary for that particular key. So we are using a value. It's just for initiation, you can assume. Don't confuse why we are taking -1. You can take any -3, -4,
Yeah,
anything.
yeah. Yes. Initially it
okay.
was empty, then we are adding the value, okay, for that particular key. That's it.
No, but that the value of that particular key is supposed to mean the direction as well as, I mean, how many steps. I'll
So
just
that
go through
key doesn't
the
represent. Okay. So I have just
assignment first.
released the solution. Can you just anyone confirm whether it is visible or not? Just go to portal, check week 11 unit whether that assignment is visible or not. Let me check.
Just a minute.
For both week 10 and 11.
Sir,
Huh?
thank you, sir.
Yeah, thank you. It's visible for me. You can check, okay?
Sir, can
Sir,
you
I had a doubt
explain
Yes,
in it.
sir.
week
It's
9?
available.
Okay, great.
Sir, can you please explain week 9 graded assignment question 14th?
Question number 14th.
Yes, sir.
Okay. What is your doubt in that?
Sir, I am not able to understand the procedure.
Yes, it is visible.
Okay. Yeah, thank you.
It is visible now.
Question number 14. Okay. I will quickly discuss that. Thirteen, 14. So is this question based on previous few questions or independent question?
Sir, it is based on the previous question. Here the graph in the previous question, we have to see which graph is correct, and in this we have to make the procedure.
So
If
this
it
is
is
graph.
accepted.
Okay. Now let's see what's the question here. Continue the previous question. For query attendance ij other than the host, we say I is ancestor of j. Their messages are identical and accept the invitation before j. Okay, note the invitation sent out the host is a unique text message. Assume that the matrix A that represent the graph has already been computed. Suppose that takes absent matrix A to attendee I and j other than the host as input, but equal returns true if I is an ancestor of j otherwise. So what is this one? Here it is mentioned pair of attendee other than the host. We say if the message are identical and I accepted the invitation before j. So here you can see I is ancestor of j. When the messages sent to I and j are same and I have accepted the invitation before j. Okay. So this is what it is saying. I and j both have the same message and I accepted the message before j. This is what it is. Now let's see procedure is ancestor Aij. What is A? Okay, matrix. K1 I is what? Okay, I. Okay, what is the question here? Okay, Ij. Fact true. White. Okay. Now, since flag is initialized to true, this is true. Flag set to false. Okay. For each C in columns of A, if you see columns of A will be this one 0, 1, 2, 3, 4, right? Hello.
Yes, sir.
Yeah. So this will be there, and then we need to check if K. What is K? I. And let's say, okay, is procedure accept I and J other than the host as the input if true, otherwise false. And let's say we take the example of this 1, 2. So I is 1, J is 2. So I accept the invitation before 2 and both got the same message. Okay, same message. This is what it is saying. Let's say I and 2 here. So I1, J2. There is an H. We know that. So let's see here. So K will be I. So K will be 1. So what about option number A? 1 and C. So we are checking from this particular node to which node we can go. So from 1 which we can go 2. So when C equals to 2, then only this condition will be true. Are you getting my point?
Yes, sir.
So when yeah, please note. See, you can take any I and J value for this graph. But I can be this, J can be this, or you can take this I, you can take this J, any pair you can take. Okay. Now see what we are getting when we say I equals to, so K equals to 1. Now here we have A, then we have K, then we have C, and then equals to 1. But K is 1. Now this condition will be true for which value of C? It means there must be some H from 1 to something. Now do we have 1 to something? Yes, 2. So when C equals to 2, that will get true. Now, this will be true. And now if we are checking C, that is 2 equals to J. J is what? 2 here. So if that is true, then we are going to return true. Okay. And then K equals to 2, we are going to exit the loop. This is for the true case. But what if we say 1 and 0? So when I say J equals to 0, that is not a case. We are not going to return true. Then we are going to exit. So A is the correct one. No. What about B?
So here K is equal to C. What is B?
Okay, K equals to C here. This we are going to return a true. So that thing is this correct. But when I take 0 and 4, let's say I0 and J4, that should return false. For I0 and J4, that should return false. So when K equals to I, so for which value of, K equals to I0, for which value of C we have a H 1,
1.
right? So this is 1. So whether 1 is equals to 4? No. So anyway, that condition is not true. Then we are updating K to what? C. K to what? We have said 1 and we are going to exit the loop. But it is not giving the false here, right?
Yes, sir.
But here we have flag is set to false initially. It is going to return false. So we are going to return true. Otherwise, we are going to exit. So value of K is what here? True. We are going to exit the. Okay. Okay. This is true, but okay. So here we are setting flag to true. And then we are exiting. And here in option number A. Yeah. Okay, what do you have any specific doubt? See, the requirement is that if I have this thing here, if I take I, this and J here, so both the node got the same message, but I got before J. So if this is true, then we are that particular position will return true. So that is what we are saying, ancestor of J. So here this should be For which value of that? Option D is not given. For false value. If that is not true, then we are set to k equals to c and flag to true, then we exit the loop. We exit the loop. Okay, again, yeah, correct, yeah. Yeah, see here, so we are only talking about Ancestor, right? 1 to 2. But what about this 3 node here? I can go to 0, I can go to 4 as well. It means that 3 and 0 receive same message, 3 and 4 receive the same message, and 3 received message before 0 and 4. Can I say like this?
Sir, 3 is the host, so he in the question it is given he can't receive any invitation or
No, other than host, na, we say that I is J, this message other than host, na, where when we say 3 is the host here, so note that each invitation sent out by nodes is a unique text message. Let assume that A matrix A represent a graph as already computed. No, that is not correct. Where we said that host is 3 other than the host, right? So IJ other than the host, we say I and J's message are identical, and I also the invitation before J. Note that each invitation sent out by the host is a unique text message. Okay. Assume that matrix A represent the graph has already been computed. Yeah, see, A and D is there is some thing. Anyway, B and C is not correct here. Okay, because this we are setting for true even if that condition doesn't match. That is not correct here for without updating the value of k. Yeah.
I think
Yeah.
in this
Do you
question,
have?
if there is he doesn't accept the invitation, there will be no edge.
Yeah.
That is
There
what.
will be no edge. Okay. Wait. Doesn't accept the invitation. There will be no edge. Yeah. So for example, 2 to 4. Sorry, 0 to 4. We don't have edge, na. So they are not the ancestor as well as they didn't receive. So when I say 0 and 4, let's try I0, J4. So it should return false in this scenario. So initially flag is set to true, then set to false. K is basically I, K is basically 0. So 0, from 0 I can go to 1. From 0 I can go to 1. So C is 1. 1 is equals to J, 4, not true. The value of K is set to C, that is basically equals to 1. Exit the loop. If I exit the loop, value of if I exit the loop, what I am going to get? Value of flag is false only, right? So if I go back to next one, so while flag is set to false, right? So this will close the while loop and value will get returned false, right? Mm, right. But what if we have a multiple condition? Is it mentioned that 3 is the host here or not? If 3 is not the host, then we can take this example. 3 send a message, both are the same message here.
sir 3 is host because in the previous question it is given that only host can give the 2 or 3 messages to anyone.
Okay, it's mentioned the previous question.
Yes, sir.
Okay, so 3 is the host, right? Great.
Yes, sir.
Okay, 3 is the host, so we are not considering that thing. So 0, 2, 1, 0, 2, 2. So if I take 0 to 2 here, procedure ancestor accept A, attendance to host other than host as input, returns true and I is the ancestor of J, otherwise false. Okay, so 0 and C is the correct answer, na? Okay, we are looking for correct map here. So this is 0, 1, and 2. So I is 0. Okay, so attendees pair of. So if 0 receives the same message as like 1 receives the same message of 0, it means that 2 and 0 same message, right? Can we say that?
Yes, sir.
Okay, is this correct?
Yes, sir.
Okay, then yeah, then correct. Yeah, got it. Identical message, accept the invitation before J. Yeah, we are not talking about 0 and 2 for also it is true because 0 and 2 both are receiving the same message and 0 accept before this one, right? Okay, okay,
Yes.
got it. Yeah, so based on the previous question, yeah, okay. So for this one, it will return true, but take for any example where it is not returning true. So 1 and 4 we can take. So I equals to 1, j equals to 4. So this is false, false C columns, right? So k is what I, that is 1. And for what value of C we are getting 1? 2. So 2, but it is equals to 4. Not correct. So we'll go to here. K equals to what? C. That is basically 2. We exit the loop and then k equals to C here, right? After for loop, k equals to 2 here. And flag is set to false. Yeah, flag is set to false only. So in the next iteration, flag will be false. So we are not going to while loop. So return, it will be flag set to false. Yeah, that is not correct here. So 0 and 2. Option A is not correct here. 0 and 2. So k is 0. This will be what for what 1. But 1 is not equals to 2. If 1 is not equals to 2, then we are going to return k equals to 2. Sorry, k equals to 1. Exit the loop and exit loop. Flag is set to false. If we go back again, flag is set to false. We'll exit the while loop. Return false. So that is not correct, right? If we say 0 and 2, it should return true, right?
Yes, sir.
But it is returning false. That's why option A is not correct. What about B? Here also, if I say 0 and 2, so I is 0, it is 1, so 1 is not equal to 2, not true. Flag is set to true, then we exit the loop here, right? If we exit the loop, again flag is set to true. So if we come back, that will be true. Again, flag is set to false. For each C, again we are going for that next thing. So again, next iteration for which value of, okay, we are not keeping a track of k here, right?
Yes, sir.
Again, this is not correct. What about C? Here flag is set to true, but return true. So here it is only set to true when this is true, but that is also not correct. Even if this is not true, we need to set to true for the next iteration. So option C is not correct. Now let's come back to option number D here. Yeah. So here if you observe, k is 0 and what we have done 2. So this is 1, 1, 2, not true. K equals to 2, flag equals to true. Now flag is true. Go for the next iteration. And there you can see for the another value, it will get true, right? So for 0, 2, sorry, C set to 1. And then we can see 1 to 2, we have a age. Then it will return true. Okay. So option D is correct here. So just take this question 0, 1, 2. Remember that 0 and 2 should, if I take I equals to 0, J equals to 2, it should give me the true value, okay? Because only we are saying message are identical. It means that whatever the message 0 got, same 1 also got, same 2 also got, right?
Yes,
So
sir.
take this example 0, 1, 2 and just try to execute that code, okay?
Okay, sir.
Okay, that's it. Thank you everyone. Thanks for
Sir,
joining.
I had a question.
What is your doubt?
Sir, activity 11.2, question number 4.
Okay, maybe we can take in the next session. Week 11, right? Week 9?
Yes, sir. Sir,
Yeah,
week
so on
11.
Monday we have session. We'll discuss in that.
Okay, sir.